Hello everyone, welcome to our last Process Mining Café for this year. Our guest today is Stefanie Rinderle-Ma from the Technical University in Munich. Hi Steffi.
Hi Anne, nice to be here.
It's great to have you. So you are the chair of Business Process Management at TU Munich, and you're regularly working with manufacturing companies in your research projects. Is this correct?
Yes, this is correct. So we are very excited about the manufacturing domain and the processes there because, they offer a lot of challenges. It's a physical domain, but also with a high human involvement and also very interesting and complex processes.
Yeah, it's really this mix. So humans are still there, but the machines, and you can see things that are happening. So it's really an exciting area.
Yes.
Okay, well, welcome to the cafe. Welcome also all of you watching. As always, most of you who are watching have watched past cafes know that you can participate. So we have just below this video, there's a chat functionality. There's no password or anything that you need to join the chat. And some people had questions about this in the past, but you don't need an account or anything. You can just type your name and say enter the chat, and then you're part of the group, and you can let us know things that you want to add, or you can ask questions. And specifically for today's session, where we are talking about process mining and manufacturing, Steffi and I discussed that there is often a certain overlap or confusion in terminology, right, Steffi? That people say a certain word, and maybe we know certain words from the process mining domain, but when you use those same terms, then they might be misleading. And to give you an example, some years ago we were working with Giancarlo for his process mining camp presentation, where he was talking about a manufacturing process in Switzerland, and he was constantly talking about spaghetti diagrams. Spaghetti diagrams was kind of a term that he was using, and I was really confused about that because, as most of you know, spaghetti diagrams or spaghetti processes, that's a word or a term that we use in the process mining community as well, and we use that to refer to very complex and complicated processes that you have to deal with, and we have developed simplification strategies to deal with these spaghetti processes and things like that. But that was not what Giancarlo was referring to, but instead in the manufacturing area there's a specific technique that is called spaghetti diagram, which basically means that you're walking through the path in the manufacturing floor that is taken by the machines or products that are going through the machines. And it's like following the manufacturing floor with kind of a pencil. And then at the end, you're seeing this so-called spaghetti diagram. So it's maybe the effect might be a little bit similar, but it's a different concept. And so that was a reminder for me that we sometimes need to be really clear about terminology and also be aware if they clash somewhere. So what we wanted to do today is to keep a little bit of a running list of terms we find misleading or potentially confusing, and also ask you to let us know if you can think of any potentially confusing terms, so you can add them in the chat, and we will keep an eye on what you're saying and bring that into the session where we can. So Steffi, did you also have a term that's misleading to start with?
Yeah, I have also an example for this, and this is the very well-known, general used term of process. So just process itself, it's I would say overloaded, at least in the manufacturing domain and probably also in other domains. So, for example, process. What is a process here? So we have, when you talk about manufacturing, could be a discrete production process. And to give a little bit of a sneak preview, this is what we will be looking into. But there's also this continuous processes from process and control engineering. So, for example, if you brew beer or you do other chemical stuff. So here you have to be also precise what you actually refer to when you refer to process. And this is something where we, in the beginning also of our journey in the manufacturing domain, had a little bit of learning curve for ourselves on how to use these terms and to use it in such a way that is clear what we mean and what we refer to.
Yeah, that's a really great example. I had experiences like that in the past also, that people said, well, I want to do process mining, I have a process, but then talking to them, it turned out actually they were talking about a chemical process, and it's not directly applicable to those types of processes. Yeah,
right. Mm-hmm. Exactly, our experience.
Yes. Okay, so let's get started. And so you're doing a lot of research projects in this area. Also, your group is developing an open source process engine, CPEE. Maybe we start with that. Can you tell us a little bit what this process engine is and what it is doing?
Yeah. Sure. So we have started to develop a process engine ourselves. So as probably several groups have done. And what was our goal in mind was to have, let's say, lightweight modular process engine. So the name CPE is Cloud Process Execution Engine, and this already a little bit suggests that this is a modular way of doing it. So you can also, everything is like a service there, and you can also develop, things that you would like to have. And then we were getting more and more into this manufacturing domain. So coming from a U project and then having also the chance to work, for example, with the Center of Digital Production in Vienna back then. Then we started to develop this a bit further to a little bit customization for the manufacturing domain. And currently, I guess from point of numbers, we have 16 manufacturing scenarios across 7 different companies that are realized or that run based on this process engine. And this gives us a quite nice overview already of the different challenges and different process scenarios that are prevalent in the manufacturing domain.
Yeah, and a nice byproduct of this is that you can collect the data, right? Which, of course, with process mining, we always need data, and it's not always a problem. Sometimes there are manufacturing processes which are where there's some kind of workflow system or some kind of controlling system where the data falls out of that and can be used for process mining already. Yeah. But in other scenarios, maybe that's not the case. But if people are using this engine, then automatically they already collect data as well.
Mm-hmm. Yes, and here we are not like don't have to stick to this process engine, but the general idea is that what we learned is that we can we have this high integration power doing this. So integration power in the sense of we have many machines, we have different stations, we have different people in the process. And when you have this process idea, you can connect all of these aspects together. And this makes it very interesting also from a data collection point of view, because you can also collect data in a contextual way. This is something that we learned, and this is then very nice also when you look then on process mining and what you can do here.
Yeah. Okay, we will come back to this a little bit later, I think. So you also brought an example, right? So should we take a look at that? So I can show the slides here with the video that you brought. So so it starts playing right now. So so can you talk us through this example?
Sure. Yes. So we thought that maybe, like these concepts and what we are doing is maybe illustrated here at a concrete example. So what we can see is on the left-hand side, you can see the processes, how they are implemented in this, let's say CPE. We have a super process that consists of sub-processes that run the machine. Now on the right bottom, we can see here the part that is already in the machine. And now we can see, so you see this red colored tasks in the process, and this is what actually is currently active. And now we can see that the machine starts churning the part, the material, and that now also this production is here started. So something is milled here. So I can see the different steps. And on the very right side, it's a little bit cut. There's also a parallel small process that collects all of the different contextual data that we have with this process. So we have one data source, that's the process itself. The events are also logged, but then also we have the other source, which collects, for example, temperature, energy, fluid level inside the machine, and so on. And what I find very interesting is that you can see that these tasks that are here in the process are at a very fine granularity somehow. So we have where every little step that takes place and that is necessary to run this scenario is a process task, and therefore can be also kind of documented, or the data about it can be collected at this granularity. And such processes typically, they have two big phases. This is the production, where we are currently in. And then we will see that the next phase is the measurement of the quality of the product that we have produced. And if you think about how processes are often modeled, this would be a two-step process. It would be something like produce part and measure part or something. And when you compare this to what we see here, you can see the differences. So granularity-wise, and there's also some expectation that the higher granularity, the finer granularity here can also lead maybe to different insights. So, but now something was happening. So you can see here now the part has been produced, and now the process not only drives the machine producing the part, but also, and this is this integration that I talked about before, the robot is now taking out the part. So it's a little bit slower than in reality for video reasons, but you can see here, so this is now this grip. And there's also something happening in the process because the execution progresses, and now the robot grips the part. And so the first phase of the process is now more or less finished because the part is produced. And of course, we have this quality control also for every part here. We are producing a batch overall. And for this specific part of the batch, we are now entering the second phase, which is the measurement phase. And here we have two measurements. As we can see in the process here, we have measure with Kians and measure with micro Wu. And this is some optical measurement. And now the robot will also do this. So it's fully automated in the sense that there's no human involvement directly in the process. So before, this was often done by a human worker to measure the part, according, for example, also to engineering drawing, where you have all the dimensions and tolerances of the part. And this can now be done automatically. And you can see that both parts, like the production and the measurement, are now combined in the process. So you can connect, for example, problems, in principle, problems now with the measurement, which you detect during that phase, to the production before. And this is actually what you want, because you would like to see maybe there's, the quality of the part is not sufficient. And what was the problem in the production before? So you have this, the integration here of these two parts. And this is an optical measurement. So the part is now put in the middle of these two devices here. And also now, of course, all these measurement parameters are collected with the process. Take some time here. And then finally, after measuring this, the robot will put the part onto the tray, where we then can also see the batch. So let's see if this is then changing to the next step here. So as I said, it's a little bit slower than in reality.
How much slower is it, Steffi? How much faster would it be? Would it be something really fast, or would it be twice as fast? Or?
Yeah, it would be a little bit smoother, let's say. There wouldn't be like, so what we did is that we kind of, for example, before we took a little pause before gripping. So this would be a smooth, maybe a movement towards grabbing the part, or here also then towards the tray. Yeah, for the video taking, there was some pauses. So, but now it should be almost at the end. But I think this tray is also interesting because you can see it here. So one of these towers was already produced. Now it's the second one. And overall, there will be a whole batch of these parts then in the end.
Yeah. Yeah, that's an interesting thing. So I'm thinking about two things based on what you just explained. So first of all, the detail. Let's talk a little bit more about that, because that's completely true. Of course, if you want to specify a manufacturing process like this and have this be run by a system like that, you need to define it on a very detailed level, and maybe more detailed than you might think. So is this something that people already do? What do you find? Do they have their processes specified already on this detailed level, or is this something new for them?
Well, yes, I think the overall, this kind of processes and process support is often a bit new, particularly when it comes to this, integrating the different stations, the different machines together. But on the other hand side, I would say that the domain experts think in these kind of granularity levels somehow, because they have this view that these are all like extra logical steps. So I think it's maybe more, in my opinion, that's just a guess now. It's clearer to the domain expert than to the process modeler sometimes. What is the right granularity? Because here you need the domain knowledge to really know where the different tasks are separated from each other, kind of, Yeah.
And do you involve the domain experts then in this initial modeling task, or how does this work?
Yeah, so at the moment we model, but the processes are modeled with the domain experts, and here we try to support them. For example, they can specify the tasks and input and output in a textual manner. So this is then also, for example, important for archiving. So, for example, we have the experience that sometimes after 20 years, there's the customer coming again saying, hey, I want this part. It was produced 20 years ago, and then sometimes it's not even clear anymore how to produce the part. So this textual documentation has also some nice side effects too. And then based on that, we then take the next step towards the execution design. So we have like a more conceptual design, which is done by the domain expert. And according to our experience, as soon as they start, they cannot stop anymore. So it takes maybe some initial effort to get people into this, but then afterwards it worked very well.
Yeah, okay, that's good to know. And so here we're talking about the initial modeling, the specification of the process, but I'm thinking about the same holds true if we're thinking about the process mining aspects of analyzing and improving such a process, right? So for example, I was just thinking about one of the process mining use cases that's available also as a video by Joris Kaiser from WECO. What he really nicely demonstrated in his case is that there is like often a process improvement expert in the company. For example, he himself is a master black belt Lean Six Sigma, and he knows exactly how to analyze data also with statistical tools and do all kinds of complicated things. But he found that process mining has the benefit that it's very accessible also to the people who are working in different operational parts of the process, who have the domain knowledge. So it's exactly what you are describing here. Like maybe the modeler doesn't know, but the person who's the domain expert, they know all the detailed steps really clearly, right? So
so also we are working with people really working with the process, the domain experts mainly. And we had also some recent study, let's say, where we asked them, so what do you want from process mining, for example? I mean, there's high expectations on that. That's very good. And I think it's very true that they have these expectations. And then we asked them a little bit in more detail. And then what was interesting to us was, for example, that there are different expectations for the different stakeholders in such process. Mm-hmm. So we talked mainly to like 2 stakeholder groups. One were the shop floor workers that really work with the process, and then also the so-called process supervisors, let's say. And the shop floor workers, they're very much interested also in like data that comes with the process, for example, sensor data that exceeds, for example, a certain threshold, and then they can, for example, derive that maybe some tool was getting blunt or stuff like that. So what really then is affecting their actual work that they're doing. And the process supervisors are then more at the level, so to say, for example, what we would refer to as conformance checking, saying, okay, are there deviations from the prescribed process that we have? They're very much interested in online analysis, so what is happening right now. And also what they would like to have is something like predictions then. So these were like maybe the 2 stakeholder groups that we were then working with, and we were also talking about process mining too.
Yeah, and the domain experts, the ones who are really close to the process, are they interested in things like process improvement through technology, through data analysis, or do you find that they say, well, I know this machine, I don't need anything else for that? What's your experience there?
Yeah, exactly. So as you say, there's maybe also as in other domains, there's 1 or 2 guys who know everything about the machine, the process, and they have done this for many, many years. And actually, we have worked with people, they can hear that the machine will now have a problem later on. Yeah. And this is very nice in some way, but also, of course, that, with the whole process management, so that the problem is what happens if these people are retiring or not available or whatsoever. So there's so much knowledge in their head. And I think for the company, then it's very good to have also other ways to do this analysis, even though you have maybe these people that can really like feel the machine and crawl into the machine and do all this fixing and these kind of things. But let's say a little bit more sustainable is then putting this onto data analysis, process mining base. I think this documentation aspect, that certainly is one aspect, but also just thinking back again to the example from Joris from Weco, what he explained, what he described was that the people who he brought together for the analysis of the process, they came from different parts, right? Because everyone is a domain expert in a very localized area, for example, for this particular machine or for this particular part of the production process, but not for everything. And so basically what it allowed them was to take a step back and to look at the whole process together and get ideas about what can be improved. And for that, he wouldn't be able to do this. Because he didn't have the domain knowledge, so it needed the domain knowledge of the people who were involved, but at the same time they needed to take the step back and look at the whole process to talk about the right things, like, right, for example, if you need more, if here we have a shortage or something, maybe I can deliver this twice a week rather than once a week, for example, right? Yes. So it's a combination, I think, taking this kind of process view from a higher level, but then making it so that you actually leverage and make use of this wealth of domain knowledge that all these experts really have in there. Yes, exactly. This is again this the integration part, that you not only look at one machine or one workstation or something, but you can, with the process, you can integrate all of this together, and then also, of course, integrate then this expertise of different people, stakeholders, domain experts working in this. I totally agree.
And then even the quality measurements, but that's something we come back to later. First, I wanted to come back to one more thing about when you showed the video and of the system, and when we talked about that the process needs to be specified, but also it allows you to collect data, right? But when you then collect the data, you also need to decide make certain decisions, like, for example, what the case ID, activity name, timestamp is. Yeah. Is this always clear, or are there also choices?
Yeah, this is something that we also learned by doing this. So this was not clear upfront to us that, for example, already the decision, what is an instance, so what is a case in this process, is already some decision that is very important and has a lot of implications when it comes to process execution and then also the design of the process, but also then on the process mining, what you can then actually derive from that, what are your insights. And so, for example, the main experts there, so we would, or I would, maybe I talk about myself, intuitively say, okay, well, one of these parts that we saw before, one of these parts that we produced, that's the instance, so don't think too much about it. But then we learned, no, this could be also the batch. So we saw at the end this tray of where the different parts were put on. And the domain experts might also think in batches, that an instance corresponds then to a batch, or even they could take a machine point of view. So they say, okay, the instance is from the perspective of one machine. And this is already interesting then to learn about this, that this also is, of course, some domain consideration that you should make before.
And it's potentially misleading also, right? If you just talk about instance and you think about a product or a part, and they hear instance and they think batch, and then you're basically using the same word, but you're thinking about something.
Exactly, yeah. Mm-hmm.
Okay, so we can add this to our running list of ambiguous terms. So we have spaghetti diagram, we have process, we have instance versus batch, perhaps. So like we said, if you can think of other potentially misleading terms, let us know. We're really curious. All right, so maybe one thing that I'm also really interested in hearing a little bit more about is the whole aspect of data. So you mentioned already the system also allows you to integrate data. There's data measurements that are happening, for example, for quality reasons. Can you tell us a little bit more about what kind of data you find in these types of processes?
Yeah. So first of all, we have the processes, and we, of course, log the events that are emitted by executing these processes. Then we have the process data itself. So this is the data that is, let's say, exchanged during process execution to run the process. And now, let's say, in addition, what we can collect too is then context data. So context data in the sense that it's not data that is directly in the process data context, but outside the process somehow. So, for example, the sensor data. So sensor data is anyway collected. So there are a lot of sensors. So if you have like one of these parts, as we saw before, you have 80 different sensor streams that are collected during this production. And we thought this could be a very valuable source of information to learn more about the process. And then, of course, as you said, these measurements, for example, of the part. This could be then process context data, of course, because it's necessary for example, then in the end, make a decision if the part is okay or not. But in connection with the sensor data could become much more interesting to see, for example, if there are problems with the quality and why these problems occurred.
Yeah. Okay, so different categorizations of data, and you do different things with them, right? So we also, I think, is this something that we can see in the slide that you brought?
Yes.
Maybe, yeah. So let's maybe take a quick look at that.
Yeah, here we try to categorize a little bit what we have. So this would, for be, for example, the output of the process execution in terms of the event log or event stream. If we look at it during runtime, it depends.
Maybe just a quick note, because
Sure.
In the last Process Mining Café, we were talking about event log standards, and we were also talking about the old MXML and the new XCS format, among other formats. So this is exactly an XCS data sample. So you can watch the previous café if you want to learn more about that. But is this coming out of the system in XCS?
Yes. So it's XCS based. So we use a little bit of serialization, so XCS YAML, but it doesn't matter here at all. So yes, this is directly then emitted by the process execution and logged. Yeah.
Mm-hmm. Yeah, and then you have an illustration of different types of data here, right?
Yes, this is. We try to give an overview on the different data that we can collect by having like this, let's say, this connection between the process execution and the data that is collected within the process execution, and then also the connection to the, let's say, external data sources in terms of, for example, these sensor data mainly. And I would say that this sensor data is a very nice source to have more context on the process. And sensor data is, for example, not only collected in the manufacturing domain, but often in these, if I may call it, more physical domains. Also in logistics, for example, you have temperature in your maybe in your truck measured all the time, or also in the medical domain, many different kinds of sensor data like blood pressure, all these things are collected. So for all of these scenarios, it can be interesting to augment, let's say, the process event data, including the data that is written during the process execution, with these external context data like the sensor streams.
Yeah.
And
So if I understand you correctly, you use it more as as additional data sources that can be leveraged, but not, for example, as the primary data source. I'm just thinking of one time I was talking to someone who wanted to analyze the process, like how people walk through a supermarket with process mining, and they had kind of location information, how people move, like just in the on the floor. And it's clear that you can't use that type of data directly for process mining. At the very least, we were talking about it at the beginning, you need, we are talking about discrete processes. So at least you need to just make the data discrete by, for example, putting it into buckets, like person moves from segment A to segment B or something like that. So are you doing some kind of categorization or discretization, if that's a word, also with the data, or?
Yes, we definitely have some, let's say, pre-processing steps on the sensor data. So what we say in this scenario that we have here, we know the process already, right? So this is something, if you have maybe just the sensor data, then questions if you can really find out something about the process, because do you know which of the data points belongs to which of the process instances, and all these things. So we have already knowledge about the process, and also we say we know, for example, where the sensor data is connected to. Is it connected to a certain task or to the instance? So do we collect maybe, for instance, 80 different sensor streams, but we know at least that these 80 sensor streams, the time series, let's say, that we collect with these belong to this instance. So this is already, of course, some knowledge that we have doing it like this, let's say. And also we can pre-process the sensor data beforehand, before we use it. So if we have it, for example, connected to a task, we could also say we don't want to have the entire stream, but we do some aggregation on it already, or some pre-processing. So there's something called dead bending, for example, or other transformations. This is something that we do.
Yeah. Or maybe if there's a certain range, right? I could imagine that maybe a sensor, if we put temperature, if the temperature rises above a certain level, then this could be an event that's again relevant also maybe for the process control or something like that.
Definitely. This is something I find very interesting. So I think so far, for example, if we talk about data that is analyzed within process mining. So to me, decision mining, for example, comes to my mind. So Anne, you're a pioneer of this. I like this very much. I think it's super important to know what your decision rules are in the process. So how do you make your decisions? I think is super valuable, and you really should know about this. And here we could also use the sensor data, because here we might come up with rules. So, for example, if you take temperature, you could say, okay, well, I do this decision based on temperature below or above 20 degrees or something. Mm-hmm. But we see also that, for example, it's also important to know, for example, that the temperature was above 20 degrees for a certain period of time, or 3 times in a row. And if you have decision rules more in this direction, you need actually, of course, some series of data points to be able to derive such decision rules.
Yeah, that's correct. Yeah, and also, so you mentioned that there's also manual data. So can you maybe give an example, like where you would still collect data manually, and then how that might be combined with automatically collected data in some form?
Mm-hmm. So in the video that we saw before, we automized the process for this scenario. These measurements for the quality of the parts were done manually. So someone looks first at engineering drawing, for example, where they know how the part should look like. And then there's also, for example, the diameter of this produced part or something. And then afterwards you measure it, if it's in the certain tolerance or not. And now in this scenario, for example, we managed to do this now in an automatic way. So because the measurement can be automated in this sense. So but still there could be also manual steps, like measuring things, or for example, also at the workstations, there's still manual work to be done. And here, of course, it becomes more interesting to measure something about the manual work than it's clear that this is then harder to get the information here.
Yeah, but that's an interesting point that the example that you gave with the measurement to measure, basically to determine the quality. So maybe there's a certain specification that should be guaranteed. So you need to measure and then confirm, okay, the quality is good for that part. And that's one example, right? What is one thing that has to be right about the process. So for example, if you think about from a process mining perspective, often we think about, well, what do we want to improve? So it depends very much on the process. What's the thing that you actually want to improve? For example, if you're thinking about a clickstream analysis on a website, and then you want to often improve the usability of the website and that people can find what they're looking for, right? But in the manufacturing process, very different. So it's always depending on the process what you want to improve. So I think quality is one thing, because probably if the quality isn't good, maybe you have to throw away the part and have to start over again. Yeah. So maybe that's another thing that we could maybe talk about a little bit more, like what typical things are that people want to improve in from a process mining perspective in this type of industry. So for example, one example I can think about is even taking the quality as a starting point. So that was actually coming back to the example from Joris that he gave from his process mining analysis at Weco. For them, it was the case that they had a rather long production process, and only at the very end they could actually do the quality measurements. And if it wasn't good, they had to start over again. And so for them, what they wanted to optimize was actually the duration of the process, so that they could be faster in going back and to starting over, but also, of course, the whole planning becomes much easier. So they had brought down the overall case duration, so the duration of the whole process from the beginning to the very end. And they had already brought that down, I think, from 12 weeks, something like that, to 4 weeks with Lean Six Sigma and process improvement methods. And then at that point in time, they were at a certain plateau and couldn't couldn't get any better, but that was they still had the ambition and said, well, we want to actually improve this further, and we think we can. And this is when they were going outside of their regular methods, and were looking for other techniques, and they were looking into data analysis techniques, and they found process mining, and then they made that step. And with process mining, and exactly what we talked about before, by involving the domain knowledge of the human knowledge of the people working in the process, they could generate more ideas, improvement ideas of getting this improvement, the process duration down to actually 2 weeks. So they could cut the 4 weeks down to 2 weeks, and they kept it at that. So it's not temporary, but continuous.
Yeah. Yeah, this is a very good example, and I think this is one of the side effects if you have really this also the full picture of your process, because then you know where also what implications you obtain if you optimize something in a, let's say, more isolated way, but what are the side effects on the overall process. As you said before, they could also connect all of these different experts in the different parts of the process, definitely. So if I might add something, so if you see maybe this little bit automation mining as a combined thing to do from our perspective. So we have in this video example here, one of the benefits was definitely that the manual measurement was also a little bit error prone. As often, of course, if things are done manually, So with this automized measurement, the error rate could be reduced, for example. This is also one improvement that was achieved by that, for example. Yeah. And another example is that, for example, with this all the sensor measurement also across all the stations and machines and these things, for example, it was also possible to measure and reduce energy that was used. So one of these companies that used this kind of solution, automation plus mining, won also a Green IT award with that. So this is also an example that we can bring here. And maybe finally what we can do is also with the mining then, and maybe then combining all the data sources together, what we can achieve is a better explainability of effects that we might have. So for example, we see sometimes that there's for example, a change happening, concept drift happening, you have to adapt something at the process, and why are you doing this? So if you can look into the data and can maybe make some connection to see, okay, maybe it was because we had problems with something, the machine or so, then this is also a valuable improvement. Let's say at least you understand to some extent what's going on.
Yes, actually that you brought an example for this particular process mining analysis as well, right? So let's maybe take a look at that too. So so it starts with this part. Yes,
this is this part is called GB12. It's part for valve for container ships, so it's a small part, but it's actually necessary for something quite big, let's say. And here again, it was like the process behind was also, again, these two parts. So we had the production part of the process, and then again the measurement. You can see there's this pattern happening. And then we had two things. So when we were measuring, and actually one of the parameters or data that we were measuring here is the diameter. So the diameter is definitely important, and it's specified, for example, in the engineering drawing beforehand, that this is one of the quality parameters. And when we were measuring this, and the sensor data, when we can see that, maybe can go, yes, the diameter here, you can see this is, for example, some of these time series that we were talking about before. So here, for example, in millimeter over time, we could see, using some existing method from time series analysis, very fancy name, dynamic time warping here, that somehow the time series seem to deviate from the previous ones. And what has happened is that we saw then on the actual real world part, maybe we can click here, that there were chips produced on the part that were actually influencing the measurement of the diameter, of course. because we have these quite substantial chips here. And this happens, for example, if the machine gets blunt or something. So I'm no engineer. I'm sorry if I am saying something wrong here, but actually this was the reason for that. And then if we may get to the last part, then we can use this in two ways. So what we can see in the process, due to this problem that was happening here, there was a change made to the process. So a concept drift was happening that, for example, we had an extra step, chip removal, which was not there beforehand. And with this sensor data analysis, what we can do, so we can either use it to explain ex post why a chip removal is necessary, or we could also, if the sensors start to deviate, we could also, for example, at least say there could be something happening, a concept drift might become necessary to deal with this situation. So we can use this in two ways, and this was, in this case, very obvious that this is really a problem with these chips, and so it was a nice example that where we could use this specific data here, this diameter measurement.
Yeah, and it's also a nice example from what we were talking about before, how you can leverage this additional data, right? So you have the sensor data, so detecting changes like that can be something that you can use in your process analysis also.
Yes, and you can use it also, for example, in general to make some predictions on the outcome of the process, for example. So the outcome, let's say the course level is here, for example, is the part okay or not? You could do this also in a more fine granular way, of course, the quality, but let's say very roughly you can say okay or not. And then you can, over the process, so and interestingly, it's not always necessarily the same sensor data that is influencing maybe the quality. So, but as the process progresses, you can combine this, for example, with, outcome prediction, conformance checking, whatsoever, where you think about deviations of the process execution from something that you have described before.
That's so nice to think about that. There's so many different things that are still possible, right? I mean, leveraging data and enables all kinds of very specific analysis also, especially if you have a particular domain and a particular process and you know what you're looking for. You can make very tailored and very maybe even advanced kind of data analysis just around the concrete problems. But at the same time, so that's why the range is so big. That's like kind of the very specialized end of this range. But then on the other end, we have kind of general support in general process improvement methods. So for example, we were talking about Lean Six Sigma before. So that's of course something that comes out of the whole manufacturing area. Today it's also often used in service industries. But that's kind of one set of, it's not one method, right? It's a set or a bag of different tools and methods that people use there. But for example, what they often look for is also, that's maybe another example what you can analyze with process mining also, where they're looking at downtime at a certain machine. So for example, at last year's, it was this year's Process Mining Camp actually, Klaus Kühnel from Wacker was talking about how they utilize a certain machine. And because these are so expensive machines that are, if there can be just a tiny bit of improvement being made on that the machine can be utilized better, they could actually translate that into a 17 million savings per year.
Wow!
Because they could kind of improve that also in other areas. But then at the same time, it's not just downtime on any machine, but often what people do, and I think that's also a really nice combination, and that's, I think, especially relevant for the whole, using process mining in the manufacturing space, is that you can also look into the theory of constraints. So we saw another example for that, not this year, but last year's Process Mining Camp by Lufthansa. And they were looking at logistics processes there, and they were using the theory of constraints. And with the theory of constraints, you're not just optimizing everything at the same time, but you're looking at the overall process, and you're looking at where in the process is the biggest bottleneck. So where is the biggest problem area, and then you focus your improvement efforts on that particular piece, and then you optimize that machine, for example, that doesn't have downtime, so you make sure it's used in the maximum possible way, and you try to work towards this bottleneck in the best possible way so that it never runs out of pieces to put into and these kind of things. And then only once you have resolved that, you're moving, let's say, to the next kind of bottleneck, right? So it's in a way a very simple method, but just this kind of general practice of what people have been doing this for decades now, this types of analysis. But then with process mining, you can actually take the data from the process and you can directly support these types of analysis for these kind of improvement professionals.
Yes, yeah. And you can connect these bottlenecks together, right? There's maybe not only one machine having some problem or bottleneck, but in some certain order, in an spanning way. So here process mining is definitely helping a lot.
Yeah, and maybe this brings us back to also one of the points you talked about earlier already. You talked about the measurement, that it's actually done in a manual way, but maybe that's a little bit error prone because maybe it's not done exactly in the same way every time. So they were actually automating the measurements. So I think the whole topic of automation, right? It can be one of the outcomes also of a process mining analysis, for example, that you say, well, this is a part of the process. Maybe we can find to automate that. So what do you find regarding automation in this area?
Yeah, so we have looked into this currently 16 different process scenarios, and from an automation perspective, we see a whole range. So we see like this very high automation level as we saw in the video, because there was no human involvement actually, but up to also processes where there's a higher human involvement. And also what is interesting for automation is definitely your starting position. If you start from total greenfield, which is maybe not very realistic, or if you start from full legacy scenario. So for the video example, for example, we had a mix of both. So we had some legacy system machines, but also we could do our process automation, for example, and we had also this human involvement before, but then later on it was fully automized. So there's a whole mix of different initial situations that you have to be able to deal with. But in general, with the automation part, I would say that it's not a contradiction that you have also human involvement at all. So there are also nice scenarios where you can, with automation, also support humans in a very good way. So human workers, participants.
Yeah, that's a good point. Sometimes if people talk about, well, if the process is automated, why do you need process mining? It's automated anyway. So it's usually not the case that, first of all, even if you have a fully automated process, things can go wrong. But more often than not, it's a kind of a hybrid process where humans are in the loop and work together with the machines. So
yes, definitely. So for the mining part, it's very interesting to also come up probably with the processes firsthand. So we are mainly working here with the domain experts, but if there's already data also available about the process that we could use to find the models to be automated later on, this is then also very good way or to, let's say, to do something in a mixed manner. So some modeling, some mining part maybe together in some way. But then also during runtime, so this online analysis and to see what is possibly going wrong. So what came to my mind too, so what is often also a problem is, for example, when you have humans involved, that humans cause some problems, let's say, with the process. So for example, there is a huge safety aspect in the manufacturing domain. So for example, if you have really robots that are programmed to do what they do and they're very, very strong. So we have heard stories about someone stepping inside and then the robot breaks your arm or even cuts it off or something because it's just doing what it's doing. And therefore, the safety issues and also then breaks of the process execution because someone is stepping inside the safety area for some reason. This is also something that has a lot of effects and can be also nicely analyzed also by process mining techniques. For example, if you look at the temporal aspect that you definitely also have in process mining and what were then the implications that happened afterwards. So this is also something what we learned is really very interesting be analyzed there.
Yeah. And I can imagine when you go there, and now everyone is talking about, for example, robotic process automation in certain areas. But is that a term that's even that's used there, or that would be confusing probably, right?
Yeah, totally. So this is a very good example here as well. So robotic process automation actually, so as it's meant by the basic definition, does not really have anything to do with robots, in the sense that there is, as we saw before, for example, in the video, a robot like that. So it's more like it's very much task oriented. So this is for certain tasks where you, for example, also due to some legacy issues or whatever, you don't know what is really going on inside the task. And if you want to automate it, you observe, for example, the user interaction with the task or input, output. And based on that, then you put a software bot on the task and automate it. And we had maybe as a little side story, we had a real robotic process automation moment, because in the scenario that I showed before, also to start the machine, this was done manually before by a skilled worker pressing on a button. But obviously the skilled worker can do something better than starting always the machine. And then we did a robotic process automation with a real hardware, because we used a rubber finger to start the machine. And this is then something which is maybe closer to what robotic process automation suggests to be. But in general, we have also worked with robotic process automation in terms of that we had tasks where there were so high legacy requirements, let's say. So, for example, that we should have be able to access the database, but this was outsourced to some external company, and so we couldn't access it. And then we tried to find out what are input, output, and then did a robotic process automation based on this task. Yeah. So for, let's say, high legacy requirements on certain tasks, this can be also some way to come up with automation here.
Yeah. Okay, so the robotic process automation should definitely go on the list of terms you should be careful about and be really clear about what you mean when you
exactly. This robotic is maybe a little bit misleading, and also the process, because it's maybe more a task automation here. That's right. Yeah, that's a good point. And I think in terms of automation, you also mentioned sometime that you prefer orchestration as a term over automation in certain scenarios. Can you explain why that is the case? So this is also a very good example for our list, maybe. So with the term automation in the manufacturing, this is again maybe an overload the term and misleading in some sense. So therefore, for example, we prefer orchestration there, because this leads the domain experts more directly in the sense how we what we mean actually. And also I like orchestration in the sense that it reflects I think in addition to the automation part, it reflects also that you integrate different, for example, machines, different systems together. So you orchestrate a set of, as I said, machines and so on together in a process logic way. And this is what orchestration suggests, maybe even more than automation does.
That I understand what you mean. So automation in a way sounds really simple in a way, and orchestration already signals that there's actually more involved and things have to be integrated, like you said, and put together. So that's maybe also an important point regarding expectation management, right? So when someone wants to do a project in this space, do you find they have sometimes inflated expectations? Do they have realistic expectations? What do you do to manage this? And maybe what does a realistic scenario look like?
Yes, so if we follow this approach that we followed and see in the video, for example, of course you can say, you have to have someone modeling the process or finding out about the process by process mining beforehand and then doing all these things. sometimes I feel that maybe some of the trends or so existing nowadays suggest a bit that you can just say, okay, well, here's all the data and throw it in, and then your process will emerge by magic somehow. And also, I don't know your experience, but the data part is often the hardest part in such projects. So, and I think there's a general story in most of the data science, business intelligence, whatever projects that are collecting the data, preparing it, and up to the point that you can do the analysis parts is often the hard part. And we try with this automation or orchestration that we are doing to make it easier, because you have, if you do that and if you pay the effort, you have kind of guaranteed output, of course, somehow. Yeah. But starting from this, I'm also interested in, of course, looking into where can we relax this, where we can maybe say, okay, well, we go more into the wild and see the data that is out there. So we are not collecting the data into some kind of data lake here or something. It's also to some certain extent some pragmatic way we are using here, but starting from this, we also know what is actually then going on, and we could also work ourselves towards like more, as I said before, into the wild and just collecting the data that's there, where we don't know maybe what is belonging to which other data and these things. But this would be very interesting. What's your experience on this data effort, collecting the data and so on? So and maybe also in other projects, other domains or so. So
yeah, no, that's a really good point. The truth is it's really different. It really varies a lot. So what I also find is that sometimes people are really afraid and think, oh, I don't have any data, or it will be really complicated to have data. Yep. It really does not need to be that way. So sometimes it's really easy. Sometimes the data is there. So it's always that's what I always recommend. It's always worth checking what data is there, and just to see what can you do with the data that is currently available. Often maybe there are gaps, maybe there are certain steps that are not in there. So then you can still analyze it and be aware of those blind spots. Just know that you don't see certain parts, but what you do see, you can work with that. And so it really, it's different. But of course, in many situations there can be quite some work regarding the data preparation or finding the data. So it's important to be realistic about that and make an assessment first before you, for example, make the planning for your project, so that you don't run out of time and have enough time planned in to get this done.
Yeah. And maybe here the manufacturing domain is also challenging in the sense that you have so many data sources in principle there, which is very good on the one hand side, because you can probably do many things, many analysis, and get a lot of insights from it. Yeah. But then maybe really this integration part to bring the different things, different aspects together in a meaningful way is might be a challenge. Challenge here. Yeah.
Yeah, and often, so what's, I think, a really good situation is that if you can have someone, again, brings us back to what we discussed before, who has the domain knowledge, knows about the process, but also can work with the data to maybe bring it into the shape that needs to be in, if it's not completely already in the form that you need it for process mining. So, for example, Klaus from Wacker, who analyzed this machine there, he's someone who can really take the data and then transform it or put it in a different way, and then he works with that data with different analysis tools, not just process mining but others. So often I think finding those kind of people who are living between these two worlds, who still know the process, have the domain knowledge, but also can work with the data, that's often, if you can find someone like that, that's the best person to involve.
Totally, because when we collected first the data, so with these 80 sensor streams, for example, we can look into it, but we don't know what it means. Partly, of course, because we don't have the domain knowledge, and then to be able to work with the data, and then also, for example, do an interpretation of the results of what you have. Then in the end, this is often requiring a lot of interaction with the domain experts, and this is, for example, also something that we try to convey to our students. Therefore, we try to do somehow let's say with realistic data, at least data sets a business intelligence project or a process mining project and everything, and that they get some feeling that they have to be able to talk then to the domain experts and ask them about, okay, what does this mean? And for the manufacturing domain, even when some of them had to go really into the physical aspects then behind that. So why is something like this and happening and so on? This is very interesting and challenging.
Yeah, no, I completely also recognize what you're saying here, and that's maybe one of the other learning points, or let's say points of attention for someone who plans a process mining project, is that they make sure they have this access to these domain experts, to these subject matter experts. So you can't just talk with the manager and they give you some data and send you away for a few weeks and then you come back with a presentation.
Exactly.
You need to have someone in the organization who you can go to with questions, because once you start looking at the data, like you described, you will have questions like, what does this mean, or what's behind that step?
Yeah, so we also had an example. This was a huge data set. I'm not recalling exactly, but like out of really a high number of parts, let's say, if it was 1,000 or 10,000 or even more, there were like 2 were faulty, but which is a very small percentage only was faulty, and then was only, here's the data and tell us why this is happening. But because it was only so few and so on, what can you do about this? This is then this is very hard, and also don't understand probably what's going on here, and this was even close to impossible to say something about this here.
I can imagine. Yes. Okay, well, maybe I think this we talked about a lot of different aspects of this whole space and industry. There's a lot of interesting things still to do there, so maybe towards the end now, do you want to say a little bit more about current projects, what you're doing with your research group in this space?
Yes, of course. So definitely, so manufacturing is one of the application domains, but in general, we also of course, do this at a more generic level. So we're looking into also compliance a lot. Also, this is a little bit connecting to all of this data and finding the processes and so on. And what we are interested here is compliance monitoring during runtime, even doing also predictions with the compliance monitoring. And also, this is the other big source of data that we have. If we talk about regulatory compliance or technical compliance and these things, often we have to first get the constraints out of the textual sources. So this is also a huge challenge to do that. And in addition, so from the application domains, we just also started to look more into logistics and the processes there. And here also combination of, for example, how you can combine optimization with then afterwards the process mining and the automation of processes. So if you have, for example, constraints and you should plan the process in an optimum way, and but then the process mining, for example, the collection process mining could play back the data that is actually happening during runtime and reality, and how these worlds can also come together. This is also a future interest.
Okay, so this goes then a little bit more into operations research areas also. Interesting.
Yeah.
Yeah, there I can imagine there's a lot of interesting topics there. And what you said was the textual data, do you mean like that you need to do like some text mining or something on some data sources to process it, or?
Exactly. So we are basing this on NLP mainly, also natural language processing techniques. So we are not like the experts on this, and also not developing really new techniques in a sense, but more like methods. And what we know is probably a bit on the compliance. So what we need as an output to be able then to, for example, directly implement this within a process, or then do the compliance checking later on, or do it directly on a process and all of these kind of things. So this is also interesting and very challenging. Yeah.
Okay, so many interesting research theses and topics, papers are in this. I'm sure maybe if someone who's watching right now wants to work with your group, they can of course find you and tell you and do some projects, right?
Yes, please do. And for example, for this operations research process mining combination, there's there's a graduate school that is where I'm now part of, and there's currently open positions, if I might say this. So yes, thank you, Anne. Perfect.
Yes. Yeah. Okay, so apply for that if you want to. Yes, and I think this brings us to the end of the session. Very interesting area, processes that you can literally see, processes where you have to be a little bit careful about the terminologies that you use. So, the running list that we came up with was spaghetti diagrams, process automation, but also instance versus batch processes, right? And automation in general.
Yes. Yeah.
If any more terms come up later, I'm still curious and interested in them. You can send them to me directly, or you can send them to us via cafe@fluxicon.com. That's also the email address where you can send questions or feedback, or maybe topics that you would like to see discussed in a future Process Mining Café. So I would say, that's it for today. Thank you for joining us, Steffi. Thanks for being here.
Thank you so much. It was super interesting. Thank you for having me and this great discussion. So Great. I'm really happy you could come. So it was very good to have you here, and thank all of you also for watching. Sign up for our mailing list at the bottom of this page if you want to be notified about upcoming Process Mining Café sessions. We will be back in the new year with a new Process Mining Café on 31st of January, where we will talk about change management. So that's it for today. Thanks everyone. Have a good evening. Bye-bye. Bye.